all can see the PPTs? Yes or no? Can all of you see the PPT? Okay. So we were talking about concurrency control in the previous class. I'll just give you a briefing about what we have studied in the previous class. So when we were talking about concurrency control, I told you we are going to work with two kinds of protocols. The first one is a log-based protocol, and the second one is a timestamp-based protocol. Okay, so talking about log-based protocol, log is a mechanism to control concurrent access to a data item. So I told you what would be the advantage of using a lock in the previous class. So lock is a mechanism to control concurrent access to a data item. And there's something called as concurrency control manager, which grants the lock to a transaction. So whenever a transaction is requesting for a specific lock on a database item, the concurrency control manager is the one which gives the lock to a specific transaction. Okay. Now, data item can be logged in two ways. That is what we have spoke in the previous class. So I can lock a data item in a shared mode and exclusive mode. I can lock a database item in a shared mode, wherein I can perform only read operation. I cannot perform write operation with respect to a shared lock on a database item. Okay. And the second lock is exclusive lock, wherein I can perform read as well as write operation. So whenever you want to read and write a particular database item, you have to acquire an exclusive lock on that particular database item. Okay. Now, xlock is requested using lockx instruction. Clearly, I told you in the previous class. So this way we go about it. Lock X on a database item A. That is with respect to exclusive lock, and lock S with respect to database item A. That is with respect to your shared lock. And there's something called as a lock compatibility matrix. So which locks are compatible with respect to two transactions? So I've taken shared and exclusive as the columns and shared and exclusive as the rows. So out of these four options, only shared and shared is compatible. So any number of transactions can perform a read operation at the same time. Any number of transactions can perform a read operation at the same time. And I cannot give a shared as well as an exclusive lock on a particular database item to more than one transaction. Okay, I can't grant S lock and X lock at the same time. And this is an example. A transaction called T2 is performing locking. Lock shared on A, read the value of A, unlock A. So once you feel that the job with respect to a particular database item is completed, you can unlock that particular database item. But that will have its own set of problems. Okay, that will also have its own set of problems. And after that, I'm taking an exclusive lock on B, read B, unlock B. And after that, display A plus B. So if at all some other transaction is performing something on A plus B, it will lead to a problem. Okay, that is the reason you have to unlock after you complete all your operations with respect to a database item. Now this is an example. Okay, see, if a lock cannot be granted, the requesting transaction is made to wait. That is one of the problems with your simple locking technique. Right? We have already covered that in the previous class. I'm just giving you a briefing of it. If at all someone has missed the class. Okay, this is an example of how we are performing a lock. See, lock, the first statement, lock X on B. The concurrency control manager is granting the transaction T1 with an exclusive lock on B because no other transaction has acquired an S lock or X lock on particular database item B. Then what I'm trying to do is read the value of B. B is equal to B minus 50. Write the value of B, and I'm trying to unlock B so that it can be used by some other things. And there is an interleaving between T1 to T2. Lock shared on A. No other transaction is holding any kind of lock on A. So the concurrency control manager grants the lock. Now, instead of that, if at all this transaction T1 is holding an exclusive lock on A and it hasn't released at this particular point, unlock A is not there. Even though T2 is trying to acquire lock S on A, the concurrency control manager makes T2 to wait for A. That is the concept of your locking. Okay, that is the concept of your locking. Now see, granting of locks. That is what we have been talking about until now. If and there's one more problem that is COSMA, that is the concept of starvation, which is nothing but waiting. Okay, if a transaction T never makes a progress, maybe it is waiting for some other transactions to release the locks, then it is said to be starved. Okay, avoid starvation. When a transaction TI requests a lock on a data item queue in a particular mode, sir, we avoid. Yes, ma?
Sir, sorry to interrupt. A few students are waiting, sir. Can you please let them in?
Yeah, ma, I have admitted them.
Okay, thank you.
Okay. Okay. So how we can avoid starvation, ma? If at all there is no other transaction that is holding a lock on a particular data item which is requested, that conflicts with a particular mode, which might be either read mode or a write mode. Okay, and there is no other transaction that is waiting for a lock on queue and that made its lock request before TI. Okay, so there should be no other transaction waiting for a conflict mode, and there should be no other transaction which is made a request before that particular transaction has made a request. Because if at all there is a transaction waiting, that particular transaction would be given the lock on that particular database item that has been asked. So this is the concept of your starvation. Now going with the next one, after simple locking mechanism, we discussed about the two-phase locking protocols. Okay, so this consists of a growing phase as well as a shrinking phase. In the growing phase, the transaction may only acquire locks. So whatever the locks are required by a particular transaction, that particular locks are obtained with respect to that transaction. And in this case, you cannot release any lock until you reach the lock point. The next one is a shrinking phase. And by the way, lock point is a point wherein a transaction has acquired as many locks as required by this particular transaction for its execution. Okay. Next, shrinking phases. The transaction may release locks over here. So once the transaction starts releasing the locks, that particular transaction has entered the shrinking phase. Okay. And once you enter a shrinking phase, that particular transaction cannot obtain any locks on any of the database items. And this particular thing leads to the concept of problems. See, I've given example with not two phases and two phases. So here what I'm trying to do is lock S on A, read the value of A, unlock A. But what is the problem with this current transaction is it requires one more lock on B. So once I start releasing the locks, I cannot acquire any other lock. So this is not the working of locking protocols with two-phase locking protocol. This is your normal locking protocol. And here, see, here what I'm trying to do, lock S on A, lock S on B. After reading both A and B values, what I'm trying to do is I'm trying to unlock A, unlock B. Unlock A, unlock B. So here what I feel that the locking is enough for me, and hence this particular point would be the lock point. And here, once it unlocks a particular lock on a database item, it enters into the shrinking phase. Here it is growing phase start. This is the lock point, and here the shrinking phase starts. Once you enter into the shrinking phase, you cannot no longer access any more locks. So I told you what is a lock point. What are the disadvantages? It leads to deadlocks, it leads to cascading rollback, and it leads to more waiting time. And you have got variants of two-phase locking protocols. You have got variants of two-phase locking protocols. In the previous class, I was talking about these things. Conservative two-phase locking protocols. The first one is conservative two-phase locking protocols. Lock all that before you actually start a transaction. So what you have to do in conservative would be you have to lock all the database items before you actually start working. And in the previous case only, I told you, getting all the locks on the database item is highly impossible. So practical implementation of this particular mechanism is very less. Okay. Now there is no concept of deadlock because it enters into execution mode if at all it has acquired. It has acquired all the locks, or else it does not enter into the execution mode. And there might be a chance of cascading rollback happening. Okay. Is it clear, Ma? Are you able to understand, or just any problem? Is it clear? Okay. Now going with strict two-phase locking protocol, it would be the same example of your simple two-phase locking protocol with some minor modifications. In strict two-phase locking protocol, transaction does not release any of the exclusive locks until it commits or aborts. So if at all I'm not leaving the concept of exclusive locks, then no other transaction can work with those particular database items. Hence, it removes the concept of dirty reads, but the other transaction might be waiting for a particular database object. Hence, it leads to the concept of deadlock. Okay. So what is happening in the two-phase locking protocol? All of you have seen ma? Here, what is happening? I'm trying to read A. This is exclusive lock. Okay, exclusive lock on A, read of A, write of A, U of A. And after this, what I'm trying to do is, again, maybe I'm trying to acquire exclusive lock on B, work with some process. Okay, here what I'm trying to do, work with some process. And I want shared lock on C. Shared lock on C. SC stands for shared lock on C. XLA stands on what? Exclusive lock on A, and here XLB, exclusive lock on B, here shared lock on C. Okay. Now what I've done here would be, I have released the lock on A, which was exclusive lock. So what does this say? Strict two-phase locking protocol says that transaction T does not release any of the exclusive lock until it commits. So once you feel that your transaction commits, then only you can release all the exclusive locks. But you can release the concept of shared locks. So here what you can do, this is a violation of your what? Strict two-phase locking protocol, but the shared lock on C can be released. The shared lock on C can be released with respect to strict two-phase locking protocol. And next we have rigorous two-phase locking protocol. So this is a bit more stricter version of your strict two-phase locking protocol. A bit more stricter version of your strict two-phase locking protocol, which specifies that you are not allowed to unlock either a shared lock or an exclusive lock until the transaction commits or aborts. Until the transaction commits or aborts. That is the concept of your rigorous two-phase locking protocol. So if at all you have acquired, I'm talking T1, T1 is acquiring XL on A, XL on B, XL on C, and SL on D. So the first three are exclusive lock on A, exclusive lock on B, exclusive lock on C, and a shared lock on D. So with respect to the normal strict two-phase locking protocol, what I can say is, what I can say here, okay, I'll just go with one step, and after that unlock C. This is allowed because until I release a lock, I am not sure whether I want to commit or abort a transaction T1. So I have unlock C, but I haven't unlocked unlocked D. I haven't unlocked ABC. So this is a strict version. But whenever I'm talking about rigorous two-phase locking protocol, I can't even do this. I can't even do this until the transaction commits. So I can purely maintain the concept of your serializability. Okay, so this is about your strict two-phase locking protocols. This is about your two-phase locking protocols. Any problems with this, ma? You can just go through this. If at all you have any issues, you can tell. Yes, ma, do you want to go through the PPT or is it okay with you? I think from here, simple two-phase locking protocol. Just go through the PPTs, the slide for 2 minutes, ma. So this is the growing phase. This is the shrinking phase that has come down, ma. And just a small point I've missed out. You have got something called as lock upgrade and lock downgrade. So if at all you are going from S mode to X mode, it is upgrading the lock. And if at all you're going from X mode to S mode, that's nothing but exclusive to share. It is downgrading of a lock. So this is the concept of your lock point. The disadvantages: deadlocks, unnecessary wait, cascading rollback. I've told you yesterday. So this is an example on unnecessary wait, deadlock, and cascading rollback. Okay, then you have conservative two-phase locking protocol, the definition. Then you have, just go through this once. You will be usually asked a question on locking. What do you mean by locking protocols? You have to write about all these things, whatever we have just discussed. So you have to write what are the different kinds of locks, what is a compatibility matrix, what is simple locking, what is two-phase locking, and the different kinds of two-phase lockings you have to work with. Okay. Now the next one is timestamp based protocols. The next one is timestamp based protocols. This is one more method for finding the serializability order, and the protocol manages concurrent executions such that the timestamps determine the serializability. So the working would be based on the timestamps, and you can calculate the timestamps based on the system clock, or you can work with your own counter. It's up to you. Whichever way you want to work with, you can work with. So there's a system default timer that can be taken, or your normal counter. You can say T1, T2, T3, T4, so on. Okay, and usually this method goes with a timestamp being assigned to the transaction. So you are given with a timestamp to a transaction. As an example, see, assume there are 3 transactions, T1, T2, T3. So T1 entered first, T2 came next, T3 came after that. If an old transaction Ti has a timestamp Ti, so now here, how I'm working with the timestamp would be, I'm working with something called as Ti. Ti stands for timestamp of a particular transaction T1. So this would be the timestamp of a transaction. Okay. Now, if at all, timestamp of T1 is less than timestamp of T2, the order would be T1 followed by T2 followed by any number of transactions that are coming. Okay, so you are just trying to assign a timestamp in this particular concept. Okay, so see, for implementation of this, we use 2 simple methods. The first one is use the value of the system clock or use a logical counter. So how I use the logical counter would be, I'm just giving you. You can wait a minute, ma. Now see, I'm working with T1 and working with T2. And in between T1 and T2, what I'll do is maybe read A. The time is T1. Read B. I'm not using the locking over here, ma. Read B. The time is T2. I'm taking small t in order to differentiate. And at a time T3, I'm working with read C over here. So this way, I'm going to work with timestamp ordering protocol. How we are going to work with an example, I'll give you. So this is the way. So this particular thing would be the counter. I'm going with T1, T2, T3, so on, Tn. Based on the number of steps, I can work with the timestamps. Okay. So this is a small example. We'll work with the example on this. Okay. So I hope this is clear, ma. Why T1 is to execute first, and whenever you're working with timestamp ordering protocols, ma, each data item queue is given 2 timestamps. The first one is with respect to the write operation on database item queue, and the second one is read timestamp with respect to database item queue. So write timestamp is the largest timestamp of any transaction that executed write queue. So if at all a transaction has executed a write queue operation, the right timestamp would be the largest timestamp of that particular transaction. So maybe if at all I'm working at the time T3, so right timestamp of Q would be T3. And it would be the same with your read timestamp of Q. Read timestamp of Q also would be the same thing. It is the largest timestamp of any transaction that executed read Q successfully. Read Q successfully. Okay, so this I'll cover in the next class, that is tomorrow. So I'll give you the scenarios and work with a small example on how we are working with timestamp ordering protocols. Any questions in today's class, Ma? Do you have any questions? Okay, so I'll be switching on. Do you want to work with activity